Hi, my name is Thomas. I'm from Münster as well, and I would like to present to you a project we are having right now at the Institute for Geoinformatics at the University of Münster. I'm going to start with a small picture from Sao Paulo in Brazil. I visited the city 2 weeks ago, and all around the city you see this kind of clocks and displays showing the time, temperature, and this little image on the right, ar boa, which means good air, or good air quality even, which this should mean. And you see that in the city of 20 million inhabitants and a lot of traffic, and you are standing in the traffic jam and are looking on these displays all the day and all night. And I checked the data source for them, found it online, map of the government, of the regional government of Sao Paulo. And I looked at it for half a year more or less, and these dots were green all the time, which means Sao Paulo has really good air. Which, well, is the case for Sao Paulo maybe, but I would assume it's not the case in fact. And the point is, people are seeing that, the inhabitants, the citizens see this data, see this displays all around, and don't talk about air quality a lot. So I was thinking how to do that, and it's not the case for Sao Paulo, it's more a general case. I just wanted to make an example here, and because you see similar things about this data and how this data is being created, how the indexes are being calculated, and how the classification is happening all around the world. We see that in Germany as well, and few citizens would understand how air quality is being calculated and classified, and even in Germany you can't access the data in fact. So the solution for that, of course, that's why I'm here, citizen science. And I would not like to see citizens as sensors for air quality or other environmental phenomena. I would really like to go this red part up to the fourth level of Mukihaklai, extreme or collaborative science, really where they are part of the problem definition. So how is the air quality, or how is the UV radiation in my city, and up to the analysis and even maybe the publication. So old school citizen science was maybe like that, paper forms, submitting them to an entity where someone was typing it into Excel and whatever. But now, of course, we have plenty of new technologies, internet, mobile phones, apps, and whatever. So we were focusing on modern technology and came up with sensors that can be acquired by citizens, and started the project some years ago, which is the SenseBox project. And there, a special case from a scientific project, we managed to deploy a real product, which you can buy already in Germany or all around the world from a German supplier, the SenseBox, with two versions, SenseBox Home for general citizens, let's say like that, and the educational version for schools or children that may even learn at home. So the SenseBox Home for Citizens is a do-it-yourself toolkit, very transparent, where all parts are visible, where you set it up following an instruction, which at the end may look like that on a balcony. This is the version on the Zugspitze, Germany's highest mountain. It measures temperature, humidity, air pressure, UV intensity, and illuminance at the moment, and it's very open and extendable. So we're working on new sensors for air quality as well, and for cloud coverage and water quality, for example. And then it submits automatically data to a platform, which I will tell you about in a few seconds. We have a version for schools, the educational version, which I would like to focus a bit on, which even has more sensors about loudness, distances, and other things, and is being delivered in such kind of a big box for a whole class. We developed a lot of instructions, open education resources that can be followed to learn to set up the sensor stations, to build your own station, to find answers for your scientific question, and to really even learn to code it. So the focus here is also really on learning to code, learning to program. And all parts of the project are open. Open in terms of open source code, open source hardware, open education resources, and even, and that's maybe the main open, is open data. So all data gathered by these boxes is going to a website called opensensemap.org, and there it's right now we crossed around 100 million measurements in the last year. People are submitting their data to this website. Schools or school children are building their own sensor stations which delivers data there. You can see all the data there. You can download all historical data, have some basic statistical analysis tools for interpolations and time series of the data, and can access everything. With the educational part, we have an interdisciplinary approach covering really all STEM subjects, from computer science, where you maybe develop and build your station, well, through the natural sciences up to even mathematics, where you really work with the data to analyze time series, for example. A few pictures how it looks like when kids are working with our box from workshops, and here's a really nice example. I like the kids can build a little traffic counter with an ultrasonic sensor. They build it on the tabletop in class, for example, and they have to change just a few values of the measurements to really use it outdoors and count the traffic in front of their school and submit this data online. We evaluated the work with 120 kids in the last year and have really positive results in terms of motivation to work with this very haptic, hands-on devices, to see results of their programming, of their making the circuits and making the stations, and really being very optimistic about this product orientation and the reality aspects of the whole project. So if you want to know more about the project, come to the subgroup, and I even brought a SenseBox to show it to you later on. Thanks a lot.